Let's look at AOPS Introduction to Number Theory, problem 6.36. Let Tn represent the number of terminal zeros of n factorial for any natural number n, the number of zeros starting from the rightmost digit before the first non-zero digit. And then there's 4 questions here. Let's start with A. For which values of n is Tn minus Tn minus 1 larger than 0? So, when do we have a terminal 0 in the first place? Well, what's the first factorial that has a terminal 0? That's 5 factorial, which is 120, and there's 1 0 here, right? So, clearly then, T5 is 1, and T4 is 20. So, 4 factorial is 24. So, T4 is 0. So, that is 1, which is larger than 0. Well, 5 factorial has a factor of 5. And anytime a number has a factor of 5 when in its prime factorization, this factorial has an extra number of terminal zeros. So examples would be, say, 120 factorial, right? 120 clearly has 5s. Well, as 120 has 1 5 in it, right? So it has one more terminal 0 than 119 factorial. Because to make a terminal 0, which is basically times 10, you need 2 times 5. And there will always be more appearances of 2 as factors in numbers than 5 as factors in numbers. Because every 2 numbers there is a new factor of 2, but every 5 numbers there's only a new factor of 5 then, right? So for question A then, which of the values of n is Tn minus Tn minus 1 larger than 0, the answer would be multiples of 5. So all these multiples of 5, 10, 15, 20, 25, 30, 35, 40, because all of these multiples of 5 have obviously a factor or more factors of 5 in them, which then leads to more pairings of 5 times 2's, which is more 10s, which is more terminal zeros. Moving on to B then, for which values of n is Tn minus Tn minus 1 greater than 1? So here we want at least 2 more terminal zeros from this factor of 5 compared to the previous number. So this would be numbers like 25 factorial compared to 24 factorial, because 25 has 25 is 5 squared. There are 2 factors of 5 in 25's prime factorization. So there would be 2 new pairs of 5 times 2's, which is 2 new terminal zeros. So this would be multiples of 25 then. 25, 50, 75, 100, 125, etc. And then thirdly then, C. For which values of n is Tn minus 1 larger than 2? Then what numbers would this be? This would be when the new factorial, like the greatest number in the new factorial, has at least 3 factors of 5 in its prime factorization, i.e. 125, which is 5 squared, right? So, for example, 125 factorial compared to 124 factorial, right? 125 is 5 cubed, so it has 3 more 5's in this factorial, which is 3 more pairs of 5 times 2's, which is 3 more terminal zeros. And hence the answer for this would be multiples of 125, right? Moving on then. D. For how many natural numbers m where m is less than 100 are there no values of n such that Tn equals m, and also no values of n such that Tn equals m plus 1? Okay, so what does this problem actually mean then? This problem actually means that so like if we dissect this problem and try to understand what this means in terms of the factors of 5 in the factorial, this basically means there are no such values of n such that there are m factors of 5. So in the prime factorization of n factorial, there isn't any factorization of 5 to the power of m. And there's also no factorization where there is only 5 to the power of n plus 1 in the factorization. So these two cases both don't exist. Okay, so when would this take place then, right? This would take place when Tn is greater than Tn minus 1 plus 2. Okay, so why is this the case then? Why is this the case for question D? Essentially because when for example, let's say m was 34 or something, like this is a random number, right? Let's say m is 34 and n plus 1 would be 35 then. And you want to have no such number n such that n factorial has 34 terminal zeros and no n factorial has 35 terminal zeros. So the last the last possible number of terminal zeros would be n minus 1, 33 terminal zeros, and the next possible would be n plus 2, 36 terminal zeros. So this means then that for any Tn, say 36, Tn minus 1 plus 2 has to be less than 36. Because if Tn minus 1 plus 2 wasn't less than 36, then this number could be 34 or 35, which wouldn't work, right? It would have to be 33 or smaller for Tn to never equal to m or m plus 1. So hopefully that makes sense here. Okay, so going back to D then, with a more generalized conclusion, which is that Tn is greater than Tn minus 1 plus 2. Well, we know that this simplifies to Tn minus 1 is greater than 2. And what values of n is this true then, right? Well, we know from C that, because this is literally the question for C, that n would be a multiple of 125. So let's list out all the multiples of 125 and see like what we get, right, for m and m plus 1. So if we have T125, the number of terminal zeros would be, so we want to prime factorize 125 factorial, right? And 125 factorial has some other factors, and then 5 to the power of what? Well, firstly, let's count the cases where this number has at least one 5. So all the numbers that are multiples of 5, 10, 15, 25, all the way up to 125, all have at least one 5. So how many numbers are there? Well, that's 25 of these numbers, right? And then plus like numbers that are multiples of 25, because they have an extra 5, because 25 is 5 squared. So they have one more 5 here. So 25, 50, 75, 100, 125. There's 5 numbers. Lastly then, numbers with another extra 5, which is 125. It's 5 cubed. So even after getting rid of 2 5s here, there's still another extra factor of 5, which is plus 1. So 125 factorial has 25 plus 5 is 31. Oh, so it has 31 5s here. So in this case then, T124 would, so T124 then would have 24, 5 to the, would have 24 plus 4, 28. Would have 28 terminal zeros. So what numbers do we skip? We skip 29 and 30, which is m and n plus 1, because these numbers will now never exist in our function t as values, because essentially then here when you make sure that this number here is bigger than 125, you will only get more or equal number of terminal zeros. If this number is less than 124, which you will only get numbers that of terminal zeros that are less than or equal to 28. So you skip 29 and 30. So that's m and that's n plus 1. So one value of m is 29. Right? Other values then. T 250. Okay, so 250 has 5 to the power, 250 factorial as 5 to the power of, so again, how many numbers from 1 to 250 have one factor of 5 in them, right? Remove one factor of 5. Well, all the multiples of 5. So there are a total of 50 multiples of 5, right? What about 5 squared then? These numbers that are multiples of 25 have a second factor of 5. So 25 all the way to 250. There are 10 multiples of 25. Lastly, multiples of 125, which have a third factor of 5 here. So that's two numbers, 125 and 250. So that gives us that T250 is 62. And T249, if you calculate in the same way, would be 49 plus 9 plus 1, which is 59. So we missed the numbers 60 and 61, which are m and n plus 1. So m would be 60 also. Then we have t when it's how much is 250 plus 125? That would be 375. Okay, so 375 factorial has a total of, so this divided by 5, right? This divided by 5 is 37 divided by 5, so 72. Plus divided by 25, which would give us, 15. And then divided by 125, which is give us 3. So T375 would give us 75 plus 15, which is 90. And then T374 would give us 71 plus 14 plus 2. 71 plus 14 is 85, plus 2 is 87. So we skip the numbers 88 and 89, and these numbers will never exist in the function t. So there will never be 88 or 89 88 or 89 terminal zeros in n factorial. So this is m plus 1, m is 88. Okay, and then we have t when it's 500. Okay, in this case then, 500 factorial has, how many multiples of 5 does 500 have, right? From 1 to 500, there are 100 multiples of 5. And then from 1 to 500, there are 20 multiples of 25. There are 4 multiples of 125, so that would be 124. T499 then would be 121. So we missed numbers 122 and 123. There will never be 122 or 123 terminal zeros for this function Tn for n factorial. So this would be m, this would be n plus 1, and m would be 122. However, this is not our answer because in the question it says that m is less than 100 right here. So in this case, then, if we considered m larger than 100, if this question didn't have any limitation, there would be an infinite amount of m's. I believe here that works for this case. So since m is less than 100, there are only 3 answers that work: 29, 60, and 88. And those are the correct answers.